Next up, we have the energy demand of the different usages in our district and their efficiency. Energy demand for different uses can potentially be reduced by energy efficient appliances and lighting, as well as daylight sensitive lighting and shading control, and even possibly users efficiency measures. All of these need to be assessed and modeled with the inputs here. So we have 4 categories of energy demand of the different usages. The first is user plug loads. So all the electricity consumed by the users with their appliances. The second is domestic hot water demand. The third is indoor lighting. And the fourth is a general category of building operation, which is typically energy required for operation of elevators, HVAC control systems, general appliances and other such things. These values are provided for each usage category with the defaults here reflecting Austrian building code. And indicative of this is a district average, which is calculated using a weight sum with the gross floor areas provided earlier. Now, the units that are measuring that is measured here is always kilowatt hours per square meters gross floor area, which is specific to the gross floor area, so that it is comparable. Now, as you can see here, these user plug loads can vary quite significantly, especially for higher intensity usages such as schools, supermarkets, and other retail options. And here, as indicated earlier, it is also possible to change certain usages, to customize them by providing other energy demands for a certain usage. For example, here I have provided industrial use as a new, with a typo even. If I recalculate here, you would see it change the name here. And now I can, for example, change the energy demand. Now, what is not in here is thermal energy demand. This is not readily available to be modeled in this way. There is a way later on I can show you by getting into details of the calculation, but regularly from the assessment tool it's not possible. Now, some district assessment methods do not include user plug loads in the assessment of a positive energy balance. This is possible to simulate here by just setting the user plug loads to 0 if you don't want to consider them. The same things you could do with lighting, which is also typically associated with the building use rather than the building operation of heating, cooling, and ventilation. One important aspect here is that for residential, the lighting demand is already part of the user plug loads. So you need to take this into consideration. The other usages have the plug loads and the lighting separated. This has to do with the daylighting control that is used to model the lighting demand. What does that mean? That means that if the lighting received to a building is below a certain threshold, again this is calculated by the fenestration rate and the current solar irradiation, then and only then daylight sensitive lighting is applied, which gives us a more reasonable estimation of lighting demand in the district. Another way the energy demand panel here can be used is by asking the question how much the energy demand of the users would need to change in order to achieve a positive energy balance. So this can be used to tweak and see how much reduction of user plug loads is required to achieve a positive energy balance that can be seen later.